Very good morning, students. For this lecturing video session, I am going to solve a problem from the chapter projections of straight lines. So let me just read out the question and make you understand what is being asked and what are the data given here. A midpoint of AB is 90 mm long and 60 mm above HP and 50 mm in front of VP. It is inclined at 30 degree to HP and 45 degree to VP. Draw its projections. See, did you find any difference between the previous problem and this problem? Yes, there is a difference. Look at here, it says midpoint. So in the previous problems, they used to specify a line of AB or line of PQ or line of LM, measuring so much of distance. Here it says midpoint. What do you mean by midpoint? Suppose a line is there, how to find the midpoint? So midpoint means nothing but the center. So this point is, let us assume A and this is B. This could be the midpoint or center, right? So assume this is a line, right? So this point is A and this point is B, and the midpoint is nothing but the center of the line. That is called midpoint of this particular object, right? So just observe carefully how I am going to do the projections here. Let me extract the information which is given in the question, given data. A midpoint of AB is 90 mm long. What does that mean? That means the true length of the object, that is AB, true length of the object. The object is a straight line which is 90 mm. And 60 mm above HP and 50 mm in front of VP. See, as far as the previous problem is concerned, we used to draw 4 loci. What are they? Locus of A, locus of A dash, locus of B and locus of B dash. When the chapter, that is midpoint of straight line, is concerned, here I am going to draw 6 loci, right? So just observe carefully. Now the locus, that is 60 mm above HP, that is the locus distance, that is locus of M dash, locus of M dash. Locus of M dash is given, which is 60 mm above, 60 mm above HP, and 50 mm in front of VP, that is locus of M, which is 50 mm in front of VP. It is inclined. What is inclined? The line is inclined at 30 degree to HP. So it is inclined to HP. So therefore, the notation is theta. Theta is equal to 30 degree. And 45 degree to VP. So the notation for inclination, that is the true inclination with VP, can be represented by 45 degree. Draw its projection, right? Before you proceed the drawing or the projections, check you have 5 data or not. Look at here, 1, 2, 3, 4, 5. So I will be in a position to complete the projection successfully. First, I need to draw the horizontal line representing the XY, that is the reference line or the ground line. Above reference line it is VP and below reference line is HP. First, take the locus distance, that is M dash, 60 mm above HP. So from the reference line, take 60 mm. From the reference line, take 60 and draw a line parallel to XY. Draw a line which is parallel to XY. This is nothing but the locus of M dash. Locus of M dash. M dash. Next locus information, which is 50 mm in front of VP. 50 mm in front of VP. which comes in the HP. So take 50 mm from the reference line And suppose assume this is a 50, draw a line parallel to the reference line. Draw a line parallel to the reference line. This is nothing but locus of M. Locus of M. So I have utilized two datas to draw the locus of M dash and locus of M. So as being midpoint, I need to choose a point for the locus of M dash and M. So any point. So I am just splitting this, I am finding the midpoint of this and draw a projection line. There is a projector. So in the previous problem, what we used to do was, we choose the locus of A and locus of A dash some point in the left extreme, right? So as being midpoint, we have to just choose a point somewhere in the mid of the locus of M dash and M, right? So I am choosing here, this I am just taking this as M dash and this point as M, right? So next I am going to utilize the third data, which is theta, that is the true inclination with HP, which is 30 degree. Now keep the protector in this manner. From the right extreme, take 30 degree and draw a line passing through M dash above as well as below the locus of M, right? Similarly, for M also you will have to take 45 degree, right? Take 45 degree. Keep your protector in this manner. Keep your protector in this manner. Take 45 degree from the right extreme and draw a line passing through the midpoint below as well as above. Clear? So I can utilize both the information. So I need to know the other two locus, that means 4 loci. Here locus of B dash, locus of A dash. Here locus of A and locus of B. Then only I will be in a position to rotate to get the final top view and final front view, right? So here the true length is given. True length is 90. Assume this is 90 mm. What would be the midpoint or center of this straight line? It could be 90 by 2. So 45 is the midpoint of this particular object, right? Suppose it is 60 mm, then it could be 30, right? The midpoint would be 30. If it is 100, then the midpoint would be 50. Here the given length is 90 mm. The true length of this object is 90 mm. So take 45 mm in your compass and keeping at M, cut an arc on the line which is extended at 30 degree above as well as below. So the intersection point above the locus of M dash, draw a line parallel to XY, the intersection point. This is nothing but locus of B dash. And below the locus of M dash, draw a line parallel to the XY passing through the intersection point, and this is nothing but locus of A dash. Clear? And the intersection point on locus of A dash is termed as A1 dash, and the intersection point on locus of B dash termed as B1 dash. The same procedure needs to be repeated in the HP also. So here take, without changing the radius, that is 90 by 2, that is 90 by 2, 45 mm. So take 45 mm in your compass and cut an arc in both the way. So below the locus of M and above the locus of M. And now draw the line passing through the intersection, which should be parallel to the XY line. It should be parallel to the XY line. This is named as locus of A, and here this should be locus of B. And the intersection point on locus of A is termed as A2. and the intersection point on locus of B is named as B2. Right? This is 30 degree, right? This is to inclination, that is nothing but theta. Theta is equal to 30 degree. Here the inclination with VP, that is pi, equal to 45 degree. Any other data left out? No, we have already found the locus of A dash, B dash, locus of A, B. Now need to do the projections, right? So here what I am going to do is from A1 dash I am going to draw a projector till it intersect the locus of M. Draw a line which should be perpendicular to the reference line till it meets the locus of M. So the A1 dash becomes A1. Similarly, for the point B1 dash, draw a projector line. There is a draw a projector which should be perpendicular to XY and till it intersects the locus of M. Locus of M. And B1 dash becomes B1. And the distance between A1 and B1 is nothing but the top view length. This is nothing but the top view length. And A2, B2 is the true length. Similarly, A1 dash, B1 dash is the true length. Got it? Now, the same manner I need to do the projection for the top view length, sorry, the true length is there, right? The top view, the true length is there. From here, I need to do the projection till it intersects the locus of M dash. This also should be perpendicular to the reference line. So A2 becomes A2 dash. Similarly, for B2, draw a projector till it intersects locus of M dash. So this B2 becomes B2 dash. B2 becomes B2 dash. The distance between A2 dash and B2 dash is nothing but the front view length. This is nothing but the front view length. The method which is adopted for projection of straight line is the rotating line method, right? Here I have the front view length, in the HP I have the top view length. Now observe carefully. So now take the measurement from M dash to P2 dash in your compass and rotate towards locus of B dash, because the information here is B. So this information comes from the locus of B. Therefore, this needs to be rotated towards locus of B dash. So measure the distance between M dash and B2 dash in your compass. M dash as center, cut an arc till it intersects the locus of B. So this point becomes B dash. Got it? Similarly, measure the distance between M dash and A2 dash. M dash and A2 dash. And M dash as center, cut an arc towards locus of A dash, because this information has come from locus of A. Look at here, from A dash. So this needs to be rotated towards locus of A, measuring M dash and A2 dash in your compass and rotate it till it intersects the locus of A. So this point becomes A dash. Now we'll have to draw a line passing through, the line should pass through, starts from A dash, M dash and B1 dash. It should be on the same line. It should be on the same line like this. So this is nothing but the final front view. F of B is nothing but final front view. Right. Now let's do the rotating line method in the top view. So now take M to A1 as radius, this distance as radius, and M as center, rotate towards the locus of A, because this information has come from locus of A dash. Look at here, A dash to M. Measure this distance, M as center, rotate towards locus of A. Rotate it. Now it intersects on the locus of A dash, locus of A. This point becomes A. Got it? Now M2 B1 as radius, M as center. This information has come from locus of B dash. So measuring this M to B1 as radius, M as center needs to be rotated towards locus of B. Right? And this point becomes B. Now you need to draw a line, starts from A, passing through M and B. It should be, the 3 points should lie on the same line. It should be on the same line. So this line is nothing but the final top view. So after drawing this, you will have to check whether the projection is correct or not. How that can be checked? You will have to check the projectors of A dash and B dash, which are lying on the same line or not. Draw a line. It should be perpendicular to reference line. Now this is perfectly right, because the A and A dash lie on the same projectors, which is perpendicular to the reference line. And let me check B and B dash. Draw a line perpendicular to the reference line. Perpendicular to the reference line. B dash and B is lying on the same line, that is perpendicular to the reference line. So this is nothing but the projectors. So the distance between the projectors A and A dash and B and B dash on the horizontal line is called the end projector. Isn't it? So I have completed the projection. Now I need to open up a box to mention all the datas to cover up. Here AB is the true length, which is 90 mm, and the final front view is A dash B dash. Whatever measurement it comes in actual, that is by measuring it by using the scale from A dash to B dash, whatever information comes, there is a data comes, you just feed it here. Similarly for the final top view, it is A to B, whatever the actual comes, you just mention here. Then theta, which is 30 degree, and pi, which is 45 degree. Then what about alpha and beta? Alpha is nothing but the apparent angle of HP. So I just mention it over here. So alpha will be always greater than theta, isn't it? Right, alpha. And beta. Beta is always greater than pi. This is beta. So whatever value comes here, by keeping the protector in this manner, measure whatever angle you get it, you just mention it here in degree. Right. Next, the dimension. The dimension I need to do it. So for AB 90 mm, for which what I have to do is draw a line perpendicular to A to B2. Draw a line perpendicular to A to B2. A to B2, perpendicular line. Now draw a line. This perpendicular line is nothing but the extension line. Now I am going to draw a parallel line to A to B2, that is the dimensioning line. Right, this is the dimensioning line. And this is 90 mm. And this is 90 mm. This is been covered. Now locus, that is 60 mm above from the reference line. 60. And 50 mm in front for the locus of M. So since I have drawn the dimension for the true length, the two dimensions should not even intersect. So let me just mention it over here, the right hand side. So I am mentioning 50 mm, here. Then theta I have captured, pi I have captured. Next, note. So you will have to mention the all dimensions are in mm with a guideline of 5 mm. Then if at all you consider any special scaling, that also needs to be captured here. As far as this projection is concerned, I haven't used any special scaling. So I can mention that scale as true scale, that is 1:1. So since there is not sufficient space available, therefore I have not mentioned it over here, but it's your duty to cover up the notes, that is all dimensions on mm, scale 1:1. With this, I have finished these projections. Thank you.